Welcome back to ChemRchem. Today we are delving into the fascinating world of semipinacol rearrangement. If you are ready to unlock the basics and explore the four interesting types with practical examples, you are in the right place. Before we dive in, don't forget to hit the subscribe button and ring that bell for more chemistry insights. Let's get started. As a quick overview, the phenol-phenol rearrangement, which is necessary to better understand the semiphenol rearrangement. According to this, vicinal diols can be converted into the corresponding ketone or aldehyde in the presence of acid. You just look this simple example. Here you see this vicinal diol, one of the center has tertiary carbon, another center has secondary carbon. When you apply the acid, the tertiary carbon center quickly lost the hydroxy group. You will get carbocation. Since this carbocation is highly stable, after that, here the hydride ion migrated towards to this carbocation center, you will get this corresponding product. So here migration takes place from secondary carbon to tertiary carbon. You just keep it in your mind in this scheme. Let's move on. Our next slide. The semipinacol rearrangement is just a special type of phenol rearrangement in which tertiary secondary 1,2 diols undergoes an unusual 1,2 migration towards the secondary center rather than tertiary one. Here you see this vicinal diol just like we see in our previous slide. Here one of the phenyl group migrated from tertiary carbon to secondary carbon. So this one as an unusual 1,2 migration, we can say reverse 1,2 migration, which leads to generate corresponding carbonyl compound. So currently there are several variations are known in this class of rearrangement. So we collectively say this one as a semipinacol rearrangement. So this is the general description of the semipinacol rearrangement. Since magnetically all such processes are a common reactive species, that is the electrophilic carbon center, including not only limited to carbocations, is vicinal to on oxygen containing carbon. Here you see vicinal to oxygen containing carbon that can drive the 1,2 migration of either carbon-carbon or carbon-hydrogen bond in order to generate the corresponding carbonyl compound. So next we moving on some important point regarding semipinacol rearrangement, that is migrating trends. The semipinacol rearrangement migrating trends just follow the migratory aptitude of phenol rearrangement. However, is also often controlled by stereoelectronic effects. And another important point is the migratory group must be anti-periplanar to the leaving group. Therefore, most of the semipinacol rearrangement is a stereo-specific rearrangement with the inversion of stereochemistry is most of the time is observed. Next, we moving on semipinacol rearrangement classification. The classification of this rearrangement is based on the nature of the substrate used in this reaction. First, we see the type 1, the rearrangement of two heterosubstituted alcohol and their derivatives classified in the type 1 semipinacol rearrangement. In this rearrangement, a good leaving group such as O-mesylate, O-tosylate, or chlorine, bromine, or iodine, N2 plus, or thioalkyl, or selenium alkyl are usually attached to the electrophilic carbon center. The 1,2 migration is triggered by the loss of this particular leaving group under either basic condition or acid condition. Let's explore with the example. So this one of the vicinal diol, this vicinal diol has one tertiary alcohol unit as well as secondary alcohol unit. According to our semipinacol rearrangement, one of the migratory group should migrate from tertiary center to secondary center. That means that reverse 1,2 migration. So how we can make it possible? We have some techniques. Now you look one by one. When we use tosyl chloride and pyridine condition, that will selectively react with secondary alcohol rather than tertiary alcohol center. Since tertiary alcohol center is quite sterically crowding, because of that secondary alcohol selectively react with tosyl chloride, which generate corresponding O-tosylated product. After that, when you treat with lithium perchlorate and calcium carbonate condition, here calcium carbonate acts as a base that readily takes the proton from this tertiary alcohol, leads to generate corresponding alkoxide ion. After that, that lithium exchange takes place, which it generate corresponding this intermediate. So after that, now you closely look, this tertiary carbon is attached with here CH2 group as well as alkene. So according to our migratory aptitude, alkene will get more priority. Now you look how that electrons are shifting. This alkoxide ion electrons comes towards to this carbon, then followed by this alkene tertiary carbon attached bond breakdown. Then this alkene carbon migrated to this secondary carbon center, then followed by kick off the tosylated or tosylated unit, which leads to generate corresponding 7-membered ring system. So here instead of O-tosylate, we can use O-mesylate, chlorine, bromine, iodine, as well as N2 plus thioalkyl as well as selenium alkyl also. Particularly that N2 plus is a special case, so we can separately classified as Tiffano-Temgeno rearrangement. This one we will see our upcoming videos separately. Let's move on. Type 2 semipinacol rearrangement. The rearrangement of allylic alcohols and their derivatives can be classified as type 2 semipinacol rearrangement. In this case, the electrophilic carbon center is a carbocation which can be generated by addition of electrophiles into the particular this carbon-carbon double bond, which results into the generation of carbocation, which is drive the 1,2 migration process. Therefore, the rearrangement process is initiated by halonium ion or selenium cation as well as Bronsted acid or Lewis acid can be classified as type 2A rearrangement. In contrast, this rearrangement is initiated by oxocarbenium ion or thiocarbenium or iminium ion that can be classified as type 2B rearrangement. Let's move on some specific examples for in the case of each rearrangement. The first case is type 2A. Here you see this one is a allylic alcohol. When you treat the allylic alcohol in the electrophilic brominating agent such as NBS, that can readily generates the corresponding brominium ion. So for better visualization, so in this particular cyclohexane ring system, I drawn in the half chair form. Now you see that brominium ion is formed. So now this phenyl group is going to be migrated. See how that will happen. So these electrons are moved towards to this carbon center, that followed by that phenyl group is migrated from the bottom phase, that followed by these electrons are moved towards to this bromine atom, which leads to generate this corresponding aldehyde as a product. Now we should see the stereochemistry of this particular reaction. Here you see that phenyl group is migrated from the bottom phase. So now you see here the product, that phenyl group is pointing down direction. At the same time, bromine atom present in the up direction. So in this way, we can explain the stereochemistry of this particular reaction. Next, we moving on type 2B example. So this one of the allylic alcohol, this allylic alcohol has primary alcohol as well as one tertiary alcohol. So when you treat with this allylic alcohol with aldehyde in the presence of Lewis acid BF3 etherate, initially BF3 etherate readily coordinate with this aldehyde carbonyl oxygen. After that, that BF3 etherate makes this particular carbon center is electron diffusion, then followed by this primary alcohol unit readily attacks this carbon center, that followed by this electron migrated towards to this boron atom, which leads to generate this corresponding intermediate. So after that, this oxygen, one of its lone pair electrons come inside of this carbon center, that followed by kick off this unit, which leads to generate corresponding oxocarbenium ion. This oxocarbenium ion, for our convenience, we can draw like this form. So now you look, this particular alkene is electron rich. This electron rich alkene readily attacks this corresponding carbon atom, then followed by these electrons are migrated towards to this oxygen, which leads to generate new 6-membered ring followed by one carbocation. So after generation of the carbocation, here you see these electrons are migrated towards to this carbon center, that followed by this 4-membered ring is expanded towards to move into the corresponding carbocation center, which leads to generate corresponding 6-membered spiroketone as a product. So particularly in this reaction is called as a Prins-Pinacol rearrangement, since the first step up to this step is called Prins reaction, then followed by rest of the steps are quite similar to Pinacol rearrangement. For that reason, we can say this rearrangement is Prins-Pinacol rearrangement. Let's move on. Type 3 Semipinacol rearrangement. The rearrangement of epoxy alcohols can be classified as type 3 semipinacol rearrangement. So in this class, slightly complex as well as quite challenging one. Here the electrophilic carbon center corresponding to its either carbon of epoxide, and the migration is driven by acid promoted epoxide ring opening. So when you use acid, your epoxide can be opened by either breaking of this particular bond, which leads to generate here carbocation. In contrast, if it open in this side, you will get carbocation in the third carbon. So now you see one by one, if your carbocation is generated in the second carbon, so here there is a possibility to migrate the group from first carbon to second carbon, which leads to generate corresponding ketone as a product. So in this particular case is 1,2 migration. Now you see here R1, this R1 core group is migrated from first carbon to second carbon. So this one is called as 1,2 migration. So here that epoxide ring is opened in the second carbon. So now you see the same thing. Once if you generate the carbocation in the second carbon, there is another possibility. One of the group from third carbon can possible to migrate into the second carbon, which leads to generate corresponding carbonyl compound. So in this particular shift is called 3,2 migration. So instead of breaking this particular bond, if you break this bond, you will get carbocation in the third carbon. So if you generate the carbocation in the third carbon, so there is a possibility to moving the group from second carbon to third carbon. That's called 2,3 migration, which leads to generate corresponding carbonyl compound. So this is the final one. Here you see, if you generate the carbocation in the third carbon, so there is a possibility to migrate the second carbon attached groups into third carbon. So this one also called as a 2,3 migration, which leads to generate corresponding carbonyl compound as a product. So here, depending on the structural features of the substrate and the reaction condition, the rearrangement can be proceed via either 1,2 migration or 2,3 or 3,2 migration. Let's see type 3 semipinacol rearrangement with on some interesting examples. First, 1,2 migration. The acid promoted semipinacol rearrangement of epoxide by 1,2 migration is common. There are several examples are known. Now see this with on one interesting example. This one is a simple example for 1,2 migration. So here you see this 2,3 epoxy alcohol is treated with yttrium triflate, which can readily rearranged to give corresponding hydroxyketone as a product. So next see this by mechanism. So initially yttrium triflate coordinate with epoxy oxygen as well as alcohol group. So which results that generate this corresponding intermediate. Because of that coordination, this Lewis acid can make this particularly that second carbon is slightly electrophilic center. Now these electrons are shifted towards to this first carbon, which make that phenyl group is migrate to second carbon center. Since phenyl group has more migratory aptitude when compared to the methyl group. So because of that migration, so here you see these electrons are shifted towards to this oxygen center, which leads to generate this corresponding hydroxyketone as a product. So here you see that phenyl group is migrated from the bottom phase, since the top phase is highly occupied by epoxide ring as well as methyl group. So remember that semipinacol rearrangement would undergo stereo-specific rearrangement. So this is one of the example for stereo-specific semipinacol rearrangement reaction. Next, moving on, type 3 3,2 migration. 3,2 migration is slightly rare type of semipinacol rearrangement. Only few examples are known. So here you see one of the interesting example. So this one of the 2,3 epoxy alcohol derivative. When you treat with Lewis acid BF3 etherate, that readily coordinate with that epoxy oxygen, then followed by generate the stable carbocation. So here you see that carbocation will generate in this particular center, since that phenyl group will stabilize that particular carbocation. So for better visualization, we can draw like this. So now you see this CH2 group from the third carbon exactly arranged in the perfect anti-periplanar arrangement. So now you see these electrons moves towards to this third carbon, then followed by this CH2 group migrated into the second carbon center. So which leads to generate corresponding ring contracted product. So this type of 3,2 migration is mainly takes place due to the structural features of rigid ring system. Let's move on. Type 3 2,3 migration. The 2,3 migration takes place when third carbon center, particularly this third carbon center, is able to stabilize the carbocation intermediate or having the more substituent on the third carbon, which usually undergo 2,3 migration in the semipinacol rearrangement reaction. In addition to that, the use of sterically hindered Lewis acid sometimes trigger the rearrangement should go with 2,3 migration sequence. So let's see some simple example based on 2,3 migration. So when you treat this epoxide with some sterically hindered Lewis acid, which readily coordinate with epoxy oxygen, which makes the stable carbocation intermediate. Now you see this is the third carbon. When you coordinate with Lewis acid, this electron moves towards to the aluminum. Here you see that carbocation generated in the third carbon, because the third carbon can stabilize this carbocation intermediate. So after that, that alkyl group migrated from second carbon to third carbon. So this migration event initiated by this electron shift. Now you see this electron coming towards this carbon. At the same time, this bond breaks down to migrate into the third carbon center. So this one is a 2,3 migration. So which leads to generate this corresponding aldehyde as a product. Next, we moving on type 3, one more 2,3 migration. Just like previous case, the 2,3 migration takes place if the third carbon center is able to stabilize the carbocation intermediate or having more substance. So here you see, this is one of the example for this 2,3 migration. When you treat this epoxy alcohol derivative with aluminum based Lewis acid, this aluminum based Lewis acid readily coordinate with epoxy oxygen followed by this electron shifted, which leads to generate corresponding stable carbocation intermediate. Now you see this carbocation intermediate will be stabilized by this 4-methyl phenyl group. So now you see what happened. This electron shifted here. The same time, the second carbon containing methyl group, this methyl group migrated from second carbon to third carbon, which leads to generate corresponding ketone as a product. So now you see the stereochemistry of this particular compound. Here methyl group is migrated in the top phase. So for that reason, we are getting this stereochemistry containing products. Not only 2,3 epoxy alcohol derivative, even simple epoxide and 2,3 epoxy ketone also undergo semipinacol rearrangement reaction. Here you see that epoxide which readily coordinate with Lewis acid that will generate some stable carbocation intermediate and followed by 1,2 shift takes place which generate corresponding carbonyl compound as a product. So here you see one of the example for simple epoxide. So this one is a cyclohexene epoxide which coordinate with Lewis acid, resulting that generation of respective carbocation intermediate. So after generation of this carbocation intermediate, you see these electrons moving towards here, then followed by this bond migrated towards to this carbocation center, which leads to ring contraction takes place, resulting that generation of 5-membered ring containing ketone as a product. So just like our simple epoxide, 2,3 epoxy ketone also undergoes similar type of reaction. Here you see this 2,3 epoxy ketone when you treat with BF3 etherate as a Lewis acid, which readily coordinate with epoxy oxygen, then followed by, here you see this electron moves towards to here, which resulting that generation of stable carbocation intermediate. After generating stable carbocation intermediate, this acyl group is migrated towards this carbocation center, which results generation of corresponding carbonyl compound as a product. So next we moving on type 4 final semipinacol rearrangement. So in this case, tertiary alpha hydroxy ketone or imine that can readily rearranged into the corresponding carbonyl compound in the presence of either base or acid condition. So this is one of the example. Here you see that alpha hydroxy, tertiary alpha hydroxy ketone is treated with aqueous potassium hydroxide. Under this condition, this compound is rearranged into the 6-membered alpha hydroxy ketone as a product. So this type of rearrangement is specifically known as acyloin rearrangement or alpha ketal rearrangement. This type of rearrangement also comes under the banner of semipinacol rearrangement. So next we see the mechanism. Initially that hydroxide ion readily takes the proton from this alcohol group So resulting that generation of corresponding alkoxide ion. So after that, this alkoxide ion negative charge shifted towards to this carbon center, that followed by this tertiary carbon migrated towards to the carbonyl oxygen. So resulting that generation of this alkoxide ion intermediate and followed by abstraction of proton from water molecule that generate corresponding alpha hydroxy ketone as a product. Importantly, this particular rearrangement is reversible reaction resulting that more stable alpha hydroxy ketone can be isolated. Next, we are moving on some important points regarding semiphenacol rearrangement. When compared to the phenacol-phenacol rearrangement, semiphenacol rearrangement has higher advantages like large substrate scope. For example, in phenacol-phenacol rearrangement, we can utilize only vicinal diols. But in case of semiphenacol rearrangement, we can utilize large array of substrates such as epoxide and allylic alcohols. Those can be easily converted into the corresponding structurally diverse products. So next point is reaction condition. In phenacol-phenacol rearrangement, we should use only acid reaction condition. But in case of semiphenacol rearrangement condition, we can use either acidic condition, basic condition, or even thermal reaction condition too. And third point is regioselectivity. In phenacol-phenacol rearrangement, regioselectivity is one of the main issue. But in case of semiphenacol rearrangement, generally provide high or better regioselectivity. And finally, migrating trends. In semiphenacol rearrangement, just follow the migrating trends of phenacol-phenacol rearrangement. However, it's often controlled by stereoelectronic effect of particular substrates. In addition to that, migratory group must be present at the anti-periplanar to the leaving group with inversion stereochemistry also observed. And there you have it. Semiphenacol rearrangement in all its complexity and beauty. We have covered the basics and unlocked the 4 interesting types through some specific examples. If you enjoyed this content, give it thumbs up, subscribe for more, and let me know your thoughts in the comments below. Until next, bye bye.